Right now, as you're watching this video, everything we thought we knew about the birth of our universe is being rewritten. The James Webb Space Telescope just captured an image that has left astronomers staring at their screens in disbelief. Og, a fully mature spiral galaxy that shouldn't exist for another billion years. But here's what's really terrifying scientists. If this galaxy exists, then either our fundamental understanding of physics is wrong, or we're missing something massive about how the universe actually works. When NASA launched the James Webb Space Telescope, scientists expected it to become a kind of time machine. Its powerful infrared sensors were designed to peer across billions of light years and capture the faintest glimmers of the very first galaxies. The plan was straightforward. Webb would help astronomers look back to a period not long after the Big Bang, when the cosmos was still young, raw, and chaotic. At that stage of the universe, only a few 100 million years after its birth, the first stars had just begun to flicker into existence. These were massive, unstable stars, living fast and dying young. The galaxies they formed were thought to be small, messy clumps of gas and dust. Primitive building blocks that would, over billions of years, merge and evolve into the majestic spiral and elliptical galaxies we see today. But when Webb pointed its golden mirrors deep into that ancient light, it didn't see chaos. It didn't see the baby steps of a universe just learning how to create structure. What it saw instead left scientists stunned. Nestled in the depths of cosmic history, only a few 100 million years after the Big Bang, Webb revealed a galaxy that looked impossibly old. Not a scattered, unshaped cloud of stars, but a fully mature spiral galaxy, complete with sweeping arms and a brilliant, organized core. In other words, the telescope discovered a cosmic giant that simply should not have existed at that moment in time. To put this into perspective, think about the timeline. Our universe is about 13.8 billion years old. According to every major model of cosmology, it should take billions upon billions of years for a galaxy to collect enough matter, enough heavy elements, and enough stability to sculpt itself into a structure as refined as the Milky Way. Yet this galaxy had already reached that level of maturity in a fraction of the time, less than 400 million years after everything began. For astronomers, this was not just unexpected, it was impossible. It was like opening a history book on the very first chapter and finding a story that belonged at the very end. Something was out of place, and it challenged the very foundation of how we understand cosmic evolution. Webb wasn't just taking a picture of deep space, it was taking a picture of a paradox. The data suggested that galaxies were capable of evolving at an astonishing speed, far beyond anything predicted by the standard models of physics. If this was true, it meant that the universe had processes, mechanisms, or even laws of nature that scientists had never imagined. It raised questions about the very flow of time in the cosmos, the conditions of the early universe, and whether our most trusted theories had been missing a crucial piece of the puzzle all along. This single discovery was enough to ignite heated debates across the scientific world. Was this galaxy a one-off anomaly? A strange outlier that somehow cheated the rules of cosmic evolution? Or was it a signpost, evidence that the story of the universe's beginning is far more complex and far more mysterious than we ever dared to believe? Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. The James Webb Space Telescope had just begun its mission. Yet with this first revelation, it cracked open a mystery so deep that it threatened to rewrite astronomy from the ground up. For more than a century, scientists have built an extraordinary story about how the universe grows. It begins with the Big Bang, a fiery birth when space and time themselves exploded into being. Out of that chaos, hydrogen and helium filled the cosmos, and over countless eons, gravity slowly pulled matter together into stars and galaxies. This is the foundation of what's known as the Standard Model of Cosmology. According to this model, the universe unfolds in clear stages. First, the Dark Ages, then the ignition of the first stars, followed by small irregular galaxies, and finally, billions of years later, the elegant spiral and elliptical galaxies we see today. Everything has its place on the timeline. Nothing skips ahead. At least, that's what we thought. When the James Webb Space Telescope revealed that ancient spiral galaxy, the discovery wasn't just surprising. It was a direct contradiction of the timeline written into the Standard Model. By all accounts, such a galaxy shouldn't have existed until at least a few billion years after the Big Bang. The physics we relied on told us that galaxies needed vast amounts of time to gather matter, to recycle stars, and to sculpt themselves into complex forms. Yet here was proof that nature had found a way to fast-forward the process. It was as if the universe had pressed the skip button on its own evolution. Instead of a baby galaxy struggling to form, Webb had uncovered one that looked like it had already lived through an entire cosmic childhood and adolescence. In less than 500 million years, it had achieved what should have taken more than 10 billion. This discovery shook the very ground of cosmology. If galaxies could mature that quickly, what else about our model might be wrong? Were we miscalculating the age of the universe? Were our measurements of distance and redshift missing something critical? Or had we misunderstood the very forces that shape the cosmos? Gravity, dark matter, and the expansion of space itself. The unsettling truth is that science thrives on consistency. When evidence aligns with theory, confidence grows. But when evidence defies the theory, as this galaxy did, it forces us back to the drawing board. Suddenly, every textbook explanation of cosmic history seemed fragile, incomplete, perhaps even outdated. Astronomers who had spent decades refining the Standard Model now faced a haunting question. What if the timeline we built for the universe is fundamentally flawed? If galaxies could leap ahead billions of years in their development, then our entire chronology of cosmic evolution may be off by a staggering margin. And this wasn't a quiet, hidden debate. The Webb discovery echoed through universities, observatories, and research institutes around the globe. Some scientists clung to the hope that the data might be misinterpreted, that maybe the galaxy wasn't as old or as distant as it appeared. Others embraced the chaos, arguing that these findings signaled the dawn of a new era in physics, one where bold theories would be needed to explain the impossible. In the end, the Standard Model of Cosmology, the trusted roadmap of the universe, had been violated. The discovery of this ancient spiral galaxy was more than a surprise. It was a warning sign that the universe still holds secrets powerful enough to upend everything we thought we knew about time, space, and cosmic history. When scientists study distant galaxies, they don't just look at their shapes or their brightness. They read their light. Using spectroscopy, the James Webb Space Telescope breaks starlight into a cosmic fingerprint, revealing the hidden chemistry of stars, gas, and dust across unimaginable distances. What Webb uncovered inside this early galaxy wasn't just strange, it was revolutionary. According to the Standard Model of Cosmology, the very first stars, known as population 3 stars, were made almost entirely of hydrogen and helium, the two simplest elements created in the Big Bang. These stars were expected to burn hot, live short lives, and die in dramatic explosions, but their chemistry would have been primitive and pure. If this galaxy had formed so soon after the Big Bang, scientists expected to see the same signature, the raw ingredients of a universe only just beginning. But Webb's instruments revealed something altogether different. The galaxy wasn't made of only hydrogen and helium. Its spectrum was marked by the fingerprints of carbon, oxygen, iron, magnesium, and even platinum, heavy elements that were never supposed to exist at such an early stage of cosmic history. This was a staggering revelation. These metals, as astronomers call them, can only be forged in the hearts of stars. They're created through nuclear fusion, released in supernova explosions, and scattered into space, where they seed the birth of new stars and planets. In other words, the presence of these elements means that the galaxy had already gone through multiple life cycles. Stars had been born, lived out their lives, exploded, and enriched the surrounding gas, over and over again, all within just a few 100 million years. That's not just fast, it's impossibly fast. The implication was clear. The early universe wasn't a quiet nursery of slowly forming stars. It was a furnace, an engine running at full speed, producing complex chemistry at a pace that defied every expectation. This changes the entire narrative of cosmic history, because without heavy elements, planets like Earth could never form. Without carbon or oxygen, life as we know it could never exist. And yet, here we find a galaxy so early, so impossibly young, already brimming with the raw ingredients of life. Think about that for a moment. The universe, in less than 500 million years, had already created the elements that billions of years later would form you, me, and everything we know. For astronomers, the questions multiplied. How could so many massive stars form, live, and die in such a short cosmic span? Was star formation in the early universe far more aggressive and efficient than we ever imagined? Or was there some other unknown process at work, something beyond the limits of current physics, accelerating the creation of heavy elements? The deeper scientists looked, the more impossible it seemed. Instead of a quiet, simple beginning, the cosmos appeared to have raced ahead, producing complex chemistry almost as soon as it was born. And if heavy elements were present that early, it raised a profound possibility. Perhaps the building blocks of planets and even life could have emerged not billions of years later, but almost immediately after the dawn of time itself. The James Webb Space Telescope wasn't just rewriting textbooks. It was rewriting the origin story of the universe. Galaxies are not all the same. Some are ragged and shapeless clouds of stars, others are smooth, glowing ellipses, and a few, like our own Milky Way, are breathtaking spiral, with arms unfurling across the cosmos like the strokes of a cosmic painter's brush. But spiral don't just appear out of nowhere. They are the result of time, gravity, and stability. To form a stable disk with spiraling arms requires billions of years of cosmic choreography. Stars must orbit in balance, dark matter halos must hold the structure together, and gravitational interactions with neighboring galaxies often help shape the delicate arms we see. That's why, when the James Webb Space Telescope locked its golden mirrors on this ancient galaxy, astronomers were stunned. What they expected to see was a young, chaotic system, irregular, clumpy, turbulent, a galaxy still in its infancy. Instead, Webb revealed something no one was prepared for: a fully realized spiral, complete with elegant arms, a bright and stable core, and even hints of a barred structure cutting through its center. This wasn't just surprising, it was impossible, at least according to our current understanding. Spiral arms require order and time, not chaos and youth. A barred spiral requires an even deeper level of stability, something thought to emerge only in galaxies billions of years old. Yet here it was, glowing softly in the distant past, only a few 100 million years after the birth of the universe. The implications were profound. This galaxy wasn't supposed to exist, not in this form, not in this era. For it to have such structure, it must have experienced long-term gravitational interactions, the kind of cosmic conversations between stars, dark matter, and surrounding galaxies that we believed took eons to unfold. But if such complexity already existed, then our entire timeline of galactic evolution was wrong. Astronomers stared at the Webb images and asked the unthinkable: how could such an organized, mature galaxy exist when the universe itself was barely out of its infancy? Was the cosmic clock somehow running faster than we thought? Or was there an entirely new set of rules guiding galaxy formation in the early universe? Rules we have yet to uncover. For decades, cosmologists taught that galaxies slowly transformed from chaotic lumps into majestic spirals. But Webb's discovery showed that perhaps spirals were not a late development at all. Maybe they were there from the very beginning, carved into the fabric of the cosmos far earlier than anyone dreamed possible. This galaxy wasn't just a structure, it was a message. A reminder that the universe is capable of refinement and beauty even in its earliest hours. A signal that the laws we thought we understood may not tell the full story. Because if a barred spiral galaxy can exist within a few hundred million years of the Big Bang, then what else is out there, hidden in the deep dark, waiting to shatter our understanding of cosmic history? The James Webb Space Telescope had pulled back the curtain, and what it revealed was nothing short of revolutionary. The early universe was not primitive and unrefined. It was already painting masterpieces. When astronomers first measured the IB, light coming from this ancient galaxy, something unusual stood out. The glow wasn't steady. It flickered ever so slightly, showing fluctuations in brightness that didn't match the calm shine of ordinary stars. Instead, it resembled something far more powerful and far more puzzling. The signature looked strikingly similar to that of a quasar. Quasars are among the brightest objects in the universe, capable of outshining entire galaxies. But they are not stars. They are the blazing hearts of galaxies where supermassive black holes devour matter at incredible speeds. Picture this: a black hole millions, even billions, of times the mass of our Sun, pulling in gas, dust, and stars. As this material spirals inward, it forms an accretion disk, a whirling ring of matter heated to such extreme temperatures that it shines across the universe. That violent, radiant energy is what we call a quasar. But here's the paradox. To build a black hole that massive takes time, a lot of time. Even the most optimistic models suggest hundreds of millions, if not billions, of years for black holes to grow from small seeds into the giants we see in the modern universe. And yet, in this galaxy, only a few hundred million years after the Big Bang, we already see signs of one. This wasn't supposed to be possible. According to standard cosmology, the first stars, huge and unstable, may have collapsed into black holes within a few million years. These seed black holes might have been dozens or even hundreds of times the mass of our Sun. But from there, growth is painfully slow. To reach millions or billions of solar masses requires an immense amount of matter and vast stretches of cosmic time. And yet Webb's observations tell a different story. Somehow, in what amounts to the blink of an eye on the cosmic clock, black holes had not only formed, they had matured. They were already anchoring galaxies, shaping their surroundings, and blazing as quasars, visible across billions of light years. The problem is not just their size, but their speed. If these supermassive black holes truly existed so early, it means either our theories of black hole growth are wrong, or there is a missing mechanism, something unknown, that allowed black holes to skip the line, growing at rates far beyond what physics currently allows. Some scientists suggest that instead of small seed black holes, perhaps the early JWST universe created direct collapse black holes, giants born instantly with hundreds of thousands of solar masses. Others speculate about exotic physics, where conditions in the infant cosmos made growth vastly more efficient than it is today. Whatever. The explanation, the implications are staggering. Black holes, once thought to be the slow-growing monsters of the universe, may instead have been present from the very beginning, shaping the evolution of galaxies from the dawn of time. And if quasars already existed when the universe was less than 500 million years old, then the story of cosmic evolution is not one of gradual buildup, but of explosive, immediate complexity. The James Webb Space Telescope had done more than detect a galaxy. It had uncovered a paradox. Black holes too big, too early, existing in defiance of everything we thought we knew. It was as if the universe itself was whispering a secret. You still don't understand how I began. The James Webb Space Telescope was supposed to confirm our theories, to fill in the gaps, to give us sharper images of a story we already thought we understood. Instead, it cracked open a box of questions so profound that some scientists began to wonder if the very laws of physics themselves might need rewriting. The discoveries, spiral galaxies impossibly early, heavy elements where none should exist, and supermassive black holes born before their time, did not fit into the neat framework of the standard model of cosmology. That model is built on pillars: dark matter, dark energy, general relativity, and the Big Bang timeline. Webb's findings were shaking those pillars one by one. Faced with evidence that didn't add up, scientists began exploring possibilities once thought too radical to discuss outside of science fiction. One possibility: dark matter, the invisible scaffolding that shapes galaxies, may not behave the way we think. In our models, dark matter is cold, slow-moving, and passive. But what if, in the early universe, dark matter was more dynamic, interacting in ways we've never considered? Could its hidden influence have accelerated the growth of galaxies and black holes, creating order far sooner than expected? Another possibility: perhaps we're misinterpreting the very thing we use to measure distance and time, the redshift of light. For decades, astronomers have trusted that the stretching of light tells us how far away and how old distant galaxies are. But what if that interpretation is flawed? What if these galaxies aren't as ancient as we believe, but instead much closer, masquerading as relics of the dawn of time? Others have suggested that the problem may lie not in the data, but in the laws of gravity themselves. Einstein's theory of relativity has passed every test within our solar system. But what if, on the grandest scales of the universe, gravity behaves differently? Could a modified law of gravity explain the rapid, early organization of galaxies and the explosive growth of black holes? And then there are the truly bold ideas. Some theorists whisper about the possibility of parallel universes or higher dimensions, realms beyond our perception that may have influenced our own in those chaotic first moments after the Big Bang. Could the strange order we're seeing be the fingerprints of another universe bleeding into ours, leaving traces in the form of galaxies that should not yet exist? Each of these ideas challenges not just a theory, but the foundation of modern science itself. To accept them would mean admitting that our understanding of space, time, and reality is incomplete, perhaps even deeply flawed. What Webb has shown us is that the universe is not obliged to follow our expectations. It is more complex, more mysterious, and more alive with possibilities than we ever dared to imagine. And so, with every image and every spectrum it sends back, the telescope is not just expanding our view of the cosmos, it is forcing us to confront the limits of human knowledge. The early universe was supposed to be simple. Instead, it was already bursting with galaxies, black holes, and heavy elements, as though the laws of physics were playing by a different set of rules. The question now is not just how the universe began. The question is, are we even asking the right questions? When the James Webb Space Telescope sent back images of galaxies that should not exist, the scientific community found itself standing at the edge of reason. The data was clear, but the explanations? They grew stranger with every passing month. For some scientists, the only way to reconcile the impossible was to think the unthinkable. One radical proposal was the idea of cosmic time bubbles. Imagine a universe where time itself does not flow evenly. In some regions, it runs faster. In others, slower. If the galaxies Webb detected happened to form inside one of these bubbles, then they would have experienced accelerated evolution. To us, they appear impossibly advanced, but within their own frame of reality, they had far more time to grow. This idea challenges the very notion of a universal cosmic clock, suggesting that time is not uniform, but patchy, fragmented, and fluid. Other theorists pushed the speculation even further. What if what Webb is really showing us are not new galaxies at all, but echoes of a previous universe? According to the theory of cosmic cycle, the Big Bang was not the beginning, but merely the latest rebirth in an eternal sequence of expansion and collapse. The galaxies we see might be fossils, structures that survived from a universe before ours, carried over in ways we cannot yet comprehend. If true, Webb may have accidentally glimpsed not just the beginning of our cosmos, but the memory of a universe long dead. And then, there are the most mind-bending ideas of all. Some physicists, inspired by quantum theory and information science, have suggested that reality itself might not be what it seems. According to the holographic principle, our universe could be a kind of projection, a three-dimensional illusion cast from information encoded on a distant cosmic surface. If that's the case, then what Webb revealed might not be galaxies breaking the rules, but glitches, anomalies in the projection of reality itself. Like a skipped frame in a film reel or a corrupted pixel in a digital image, these galaxies could be evidence that the fabric of the universe is not continuous, but structured, coded, and fallible. Of course, these ideas sound fantastical. Cosmic time bubbles, recycled universes, holographic glitches. These are not the kind of explanations you'll find in standard astronomy textbooks. And yet, the universe is forcing us to consider them. The data is too compelling to ignore. Webb was built to peer deeper than ever before. But no one expected that depth to lead us here, to the very edges of science, where the line between physics and philosophy blurs. What is time? What is reality? What is the true nature of the universe we inhabit? The telescope hasn't answered those questions. Instead, it has raised them with greater urgency than ever before, daring us to think beyond the safe boundaries of known science. Perhaps the greatest discovery of all is not the galaxies themselves, but the realization that the universe is far stranger, far more mysterious than even our boldest imaginations had prepared us for. At first, some skeptics tried to dismiss Webb's discovery as a miscalculation. Perhaps it was a calibration error in the instruments, or a cosmic mirage created by the bending of light. After all, astronomy is delicate work. Tiny misinterpretations can lead to dramatic conclusions. But then, Webb kept looking, and what it found shattered the hope that this was merely a mistake. It wasn't just one galaxy defying the rules of cosmic evolution. It was dozens. Each time Webb turned its golden mirrors toward the deep past, the same story repeated itself. Galaxies that were impossibly massive, impossibly refined, and impossibly ancient. Some of these galaxies were as large as our own Milky Way, yet they existed only a few 100 million years after the supposed birth of the universe. According to everything we thought we knew, galaxies of this scale should have taken billions of years to assemble. Their structures should have been chaotic, irregular clumps, not elegant spirals with defined arms and luminous cores. But the wordy anomalies didn't stop at size and structure. The chemical signatures told the same impossible tale. These early galaxies weren't made of pristine hydrogen and helium alone. They were enriched with carbon, oxygen, iron, even rare heavy elements, like platinum. This meant that entire generations of stars had already lived, exploded, and seeded the cosmos with metals long before such a process was thought possible. And, perhaps most unsettling of all, some of these galaxies showed hints of active black holes, even quasars, blazing at their centers. These would require supermassive black holes, millions, even billions of times the mass of our Sun, already fully formed at the dawn of cosmic time. At this point, coincidence was no longer an option. One outlier might be an error. Two might still be a fluke. But a growing catalog of such galaxies, all telling the same forbidden story? That was a revelation. It became clear that the universe was hiding an entire chapter of its history from us. A chapter that our textbooks had skipped, that our equations had overlooked, that our theories could not yet explain. The implications were staggering. If galaxies were forming faster, growing larger, and evolving sooner than we believed, then our timeline of the cosmos was deeply flawed. The Big Bang may not have been the clean, simple beginning we imagined. The early universe was not a quiet, dark expanse slowly coming to life. It was already vibrant, structured, and burning with complexity. For scientists, this was both thrilling and terrifying. It meant that everything we thought we knew about the origins of galaxies, stars, and black holes had to be reconsidered. Webb was not just rewriting a detail or correcting a small error. It was uncovering a hidden truth about the very fabric of cosmic history. And as image after image streamed back to Earth, one thing became undeniable. The anomalies were not anomalies at all. They were the universe revealing its true story. A story far stranger and far older than we ever dared to imagine. The James Webb Space Telescope was designed to explore galaxies, stars, and cosmic history. But its discoveries may have implications far closer to home, or at least far closer to the question of life itself. When Webb revealed that galaxies in the early universe were already chemically rich, it wasn't just a triumph of cosmology. It was a hint that the ingredients for planets, oceans, and perhaps even life were available far earlier than anyone imagined. We once thought that the universe had to age for billions of years before forming rocky planets. Heavy elements like carbon, oxygen, iron, and magnesium are essential for planet building. Without them, there's no crust, no oceans, no atmosphere capable of supporting chemistry like we see on Earth. But these early galaxies contained those elements in abundance. This implies that stars had already lived, exploded, and seeded the cosmos with metals, making planet formation possible hundreds of millions of years after the Big Bang, not billions. The universe may have been ready for Earth-like worlds long before our solar system even existed. And it's not just the possibility of planets, it's the possibility of life. Where there are rocky planets with water and organic compounds, the basic building blocks of life may also be present. If the universe became hospitable so early, could life itself have emerged far earlier than we ever imagined? Could civilizations have arisen and fallen eons before humans even walked the Earth? This isn't just speculation. Webb's spectral data shows the signatures of molecules like carbon monoxide, carbon dioxide, and even hints of complex organics in young galaxies. These are the chemical seeds from which life could sprout. The timeline for cosmic biology may need to be rewritten, opening the door to civilizations older than our entire planet. The implications are staggering. If life could arise in these early galaxies, the universe may be teeming with ancient, advanced worlds whose histories are unknowable to us. Planets, oceans, and perhaps civilizations could have existed long before the sun ignited, invisible in the darkness until now. Webb's findings force us to ask profound questions. Are we alone? Or are we part of a cosmic story that began billions of years before Earth? How many worlds could have formed, evolved, and perhaps even fallen into ruin, leaving behind no trace but the chemical fingerprints in ancient galaxies? For the first time, it feels as if the universe itself is inviting humanity to expand its imagination, not just to ponder the origins of stars and galaxies, but to imagine the possibility of life on a scale and age that dwarfs our own existence. Webb isn't just showing us the cosmos, it's showing us what life might have looked like in the earliest chapters of the universe. And in doing so, it transforms our understanding of what is possible and how deeply interconnected we are with the vast expanse of space and time. The discoveries of the James Webb Space Telescope did more than rewrite textbooks. They shook the very foundation of science. What began as a mission to study the first galaxies quickly evolved into a journey that challenged humanity's understanding of reality itself. Astrophysicists, quantum physicists, and even philosophers of science were forced to confront a sobering truth. Our models of the universe are incomplete. The elegant equations and simulations that have guided cosmology for decades suddenly seemed like approximations, hints, rather than definitive answers. The universe revealed itself as far stranger, more complex, and less predictable than we had imagined. The revelations were humbling. Galaxies forming faster than physics allowed. Heavy elements appearing almost immediately after the Big Bang. Supermassive black holes and quasars lighting up a cosmic dawn we thought was still dark. These were not isolated anomalies. They were evidence that the universe contains structures, laws, and histories beyond human imagination. And yet, this uncertainty was not discouraging. It was exhilarating. Webb didn't just provide data. It ignited a revolution. Scientists no longer sought merely to confirm theories. They were compelled to ask deeper, more profound questions. Questions that bridged disciplines. Could our understanding of time itself be incomplete? Could life exist on planets formed billions of years before Earth? Could reality itself hold layers we have not yet glimpsed? This is the beginning of a new era, a renaissance of curiosity, one where mystery is not a failure of knowledge, but the fuel for discovery. Every image Webb sends back, every spectral signature it records, is a reminder that the cosmos is alive with secrets, daring us to explore further. The telescope has opened a door to possibilities that stretch beyond the limits of imagination. It challenges us to think bigger, to question harder, and to accept that some answers may be beyond our current reach. In doing so, it reminds us that science is not a static body of knowledge. It is a dynamic journey, ever-changing, ever-expanding, propelled by wonder, skepticism, and awe. The universe is no longer just an object of study. It is a frontier of the mind, a canvas of mysteries waiting to be painted with insight. And at the heart of this frontier is the James Webb Space Telescope, a beacon illuminating the unknown, daring humanity to chase the questions that may never have simple answers. We are witnessing not just the observation of galaxies, but the birth of a scientific revolution. A revolution where uncertainty is celebrated, curiosity reigns, and the universe, in all its vastness and strangeness, invites us to explore its deepest secrets. The cosmos has spoken, and humanity is listening, more boldly, more imaginatively, and more determinedly than ever before. As the James Webb Space Telescope continues to send its golden mirror glimpses across the universe, one truth becomes unmistakably clear. We are only beginning to understand the cosmos. Each discovery, each anomaly, each galaxy out of place is a reminder that the universe is far stranger and more wondrous than we ever imagined. We have glimpsed galaxies that defy time, elements that hint at early life-building chemistry, and black holes that challenge the very rules of physics. We have stared into the cosmic past and realized that reality itself may be more complex, more layered, and more mysterious than textbooks can explain. And yet, this is not a story of despair. It is a story of possibility. Possibility that worlds older than Earth could host life, that mysteries await in the farthest reaches of space, and that humanity's curiosity is the spark that allows us to chase these cosmic secrets. The universe is no longer a distant backdrop. It is a living, unfolding story, and we are part of it. What we once thought impossible is now within reach of our imagination, guided by the extraordinary eye of the James Webb Space Telescope. So, the question is no longer whether we can understand the universe, but how far are we willing to go to explore it? The answers lie ahead, in the light of galaxies we have yet to discover, in the secrets we have yet to unravel, and in the mysteries that will continue to challenge and inspire every generation of explorers, dreamers, and thinkers. The cosmos awaits, and the adventure has only just begun. If you found this journey through time and space as mind-blowing as we did, subscribe now to follow the latest cosmic discoveries. Share your thoughts in the comments. What do you think these ancient galaxies mean for life, the universe, and our place within it? Let's explore the unknown together.